Okay, thank you very much. Starting chapter 5. Chapter 5, as we know, is about rational numbers. And a rational number is any number that we can write as a fraction with an integer in the numerator and denominator. That means all fractions, obviously, but decimals that either end or repeat are going to be rational. And talking about repeating decimals, we knew that from before, from earlier in the year, 1/9 is going to be zero point 0.1 repeating, 2/9, blah, 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 3/9, 4/9, 5/9. They're all repeating decimals. 7/9 we learned was zero point 0.7 repeating. So the ninths have something to do with it. The remainder becomes the same compared to the tenth. If it is ninth, gives you a repeating remainder, which gives you a repeating decimal when we divide it out. And we did talk a little bit about this earlier in the year, but if there are 3 nines in the denominator, there's going to be 3 digits to repeat. So 125 over 999 is just going to be 0.125 repeating. All of it's going to repeat. So 0.125, 125, 125. 123 over 999. So we're looking for, again, these digits in the numerator here. They add up to 6. So 3 is going to go in here. And actually, you can divide both of these by 3 and get 41 over 333. And then again, this is 3 times 1, 11, which again is another 3, so 9 goes into this number. Because these digits add up to 9. 9 doesn't go into 41, 3 doesn't go into 41, and you're pretty much stuck here. And we remember that the number of nines is equal to the number of digits that repeat. Here, this is 0.65 with 2 digits repeating. So this is going to be 65 over 99. So 2 digits repeat, 2 nines in the denominator. If I could write this at all, you'd see what I mean. So 65 over 99. 1 digit that repeats. So there's only 1 9 in the denominator. And so the numerator was the 65 minus the part that doesn't repeat, which is the 6. And then that's over only 1 9 in the denominator, but it's a 2-digit, so it would be over 90. So this thing turns into 65 minus 6, which is 59 over 90. And then again, to see whether it reduces, I'm looking for 90 is 10 times 9, so I'm looking for 2's, 3's, and 5's. None of those go into 59. I think 59 is prime, but again, I don't really need to know. 3 digits repeat, so all 3 of these are going to be 065. So it's going to be 65 over 999. And again, I'd be looking for 3's to start, if I want to try to reduce. 2 digits repeat, so this is going to be 65 minus the 0 that doesn't repeat. Well, that's still 65. So this one's going to be 65 over 2 digits repeat, so there's going to be 2 nines in the numerator, or rather the denominator. So this is going to be over 990. So this is bringing us into play 2's and 5's in addition to the 3's, the contingent of 3's. So this one I'm going to be able to reduce because obviously 5 goes into 65. So divide these both by 5 and I get 13 over whatever that mess is. 2, 30. Eighth. I don't know, I'm just guessing. Luke Bernard. Any guesses? No. Thanks. And again, here 1 digit repeats, so we've got 1 9 in the denominator, and there's a 3-digit, so there's 3 numerals in the denominator, so this is going to be 900. So this is going to be 65 minus the part that doesn't repeat, which is 0.6. So 65 minus 6, which is 59 over 900. Again, that's going to be reduced. If you want to check those, you just divide 59 divided by 900 on your calculator. Let's see if we can do that. That sounds like fun. 59 over 900 gives me 0.65 with just the 5 repeating. Again, even though this one holds a lot of digits, it still rounds at the end. But this would be 0.65 with the 5 repeating. So 21 40ths. One way to do it is just divide the numerator divided by the denominator. 21 divided by 40 equals 0.525. Okay. 25 over 8. Again, this is one of these ones where Luke goes, I don't know, what is that, 3.125? Luke's like, oh. Well, that's true. If you do 25 divided by 8, you get 3.125. This is really just, again, 8 goes into 24 3 times, so that's 3 wholes. And then 1/8, we know that one. That's 0.125. Alright, sorry about the worst handwriting ever. Going backwards, right, we've got a terminating decimal. This decimal ends, we know, in the thousands place. So I just put the whole thing. There's no repeating part, so I don't have to do, subtract part of it or whatever. This is just the 55. If you were in 4th grade, your 4th grade teacher would say, what is that? And you'd say it's 55 and ends in the thousands place. So it's 55 thousandths. Now, the Bossert part of this is that you don't need to decide what goes into both numbers. You already know what's in, sorry about this hat on the 0. You already know what's in the denominator. The denominator is nothing but, because it's a terminating decimal, it's a power of 10. So it's just 2's and 5's. This is, in fact, 2 to the second. Sorry, 2 to the third. So it's 10 to the third. So it's 2 to the third. This is what it's going to do here. So 2 to the third times 5 to the third. Alright, 2 to the third and 5 to the third, because it's 10 to the third. And so up here, we know that this is 5 times 11, so we know we're going to cancel out. We're going to cancel out one of the 5's. Alright. And so the denominator I've got 8 times 25, which is 200. So this is going to be 11 over 200. Or you could divide 5 once. But again, I'm only looking for, in this top number, I'm looking for 2's and 5's that go in here. Alright, for this one I got 144 over 1,000 again. And I'm only looking for 2's and 5's. If I wanted to be advanced here, I'd say that there's 2 to the third, or 8, that could go in here. And I know that there's 2 4's. 44 is divisible by 4. So if I wanted to be, super slick about it, I would probably divide it by 4, which would leave me, if I took out, out of my 2 to the third, 5 to the third, I took away 2 of the 2's, I'd be 5 to the third, which is 125 times 2, which is 250. So my denominator is 250, and if I divide this number by 4, you get 36 or whatever, right? So it looks like 8 could have gone in here, because I'm going to divide another 2 out. Let's see here, 18. Oh yeah, 144 is 2 to the 12 times 12. Alright, so I can get 18 out of 125. 18 over 125. That's going to be my answer for that. So the point that I want to make here is, if it's a terminating decimal, the denominator is going to be some power of 10, which the only primes that go into that are 2's and 5's. So I'm only looking to reduce or cancel out 2's and 5's. If I wanted to take this back to chapter 4 and do 144, which would make that 12 times 12, which would be 2 to the 4th times 3 to the 2nd. And this one would be 2 to the 3rd times 5 to the 3rd. Cancel out 3 of the 2's. And that would give me down to 125. And leave me with 2 times 3 to the 2nd, which is 18. That might be the end of this section. Alright, next now we're going to talk about common denominators and adding and subtracting rationals. That's in the next section. Thank you.